Hello and welcome to Cup of Cosmology, the place for all your questions about the universe. My name is Diana Hooper and I'm a theoretical physicist currently doing a postdoc in the Helsinki Institute of Physics over in the University of Helsinki in Finland. And yeah, I'm a cosmologist, so that means that I study the universe, the contents of the universe, how things evolve, how things interact, all of the cool stuff happening inside the universe. It's a great topic. I love studying cosmology and I love chatting to everybody about all of the cool things that happen inside the universe and all of the cool things I get to study, which is still really amazing that I get to study and work on some of the coolest things in the universe. Hello to all of the regulars tuning in, David, Ange, Prath, Scott, Ben. Nice to see you all as always. Great to have all of the regulars, other David in as well. Happy 25-hour day if you change your clocks. If you haven't changed your clocks, you've hopefully noticed that we have in Europe, and therefore today we're on a different time. As always, I have to do my 6-month mandatory comment of daylight saving time is nonsense and we should stop doing this. But at least this time we got an extra hour light, which also means now it's getting dark at like 4:30 in the afternoon in Helsinki, which takes some adjusting, but it's amazing. It's the best season. Hey, Paul, great to see you. Yes, please don't type and drive. Don't focus on the road. You can pay attention to me once you finish driving. How the Helsinki, hey Anna, great to see you in the comments as always. Someday you should come on this side of the screen again, but great to see you here in the comments. So how am I doing in Helsinki? How's Helsinki doing? I am good. As you all know, I've been away the last 2 weeks. Oh, I should stop speaking so quickly. I have been away the last 2 weeks because I was hiking 2 weeks ago, went on a really fun hike that turned into a lot of like walking through swamps because we went after rain and it was bogland and it was very swampy. It was great fun. Last weekend I was once again traveling to yet another conference, which seems to be what I'm doing every other week right now. And I've literally been back 3 days and today I booked my next trip. But at least for now, Cup of Cosmology is back. And to answer the question, I am doing well. Everything in Helsinki is going well. I am hyper and I'm happy to chat to you all today. Yes, we have indeed changed the clocks. If you haven't noticed, you just missed the stream. So yeah, I guess if you're here, you've realized that we've changed the clocks or you change the clocks with us. In any case, daylight saving time, ridiculous. But today is a special stream. That seg went a bit weird there, but today is a special stream. It is 2 days before Halloween. I love Halloween. I don't care if it was a holiday that makes no sense. I don't care about the origins. I absolutely love Halloween. It's an excuse to be spooky, and I love spooky season. So happy almost Halloween to anybody who's celebrating, and even if you're not celebrating, happy week. And because it's spooky season, I thought today I would do a review of some of the fun and scary and slightly terrifying facts about the universe. So this is not going to be a light-hearted stream. We are going to get into things that may or may not terrify you. So hopefully we'll all leave here with some sense of existential dread, but also a dash of optimism. That is usually the message to take away from these streams, at least. I'm going to do some spooky facts. I'm going to do my favorite spooky fact. Now, the cool thing about the universe is there are so many possible spooky facts we could choose from. There are so many things I could have focused on for this stream. So I'm going to go through my 10 favorite spookiest facts about the universe. You might not find them all to be so spooky, but at least some of them will probably terrify you slightly. I'm going to try to keep this fun, but there's going to be a fair amount of existential dread setting in. But as always, I realize my introduction is all over the place today, but that's fine. We can just go with it. As always, this is an interactive stream, so the idea here is that you people can ask me anything you want. If anything I say is unclear, if you want to jump in and join the conversation, anything, just put it here in the comments. I always try to get through all of the comments that said. I think I've already missed comments at the beginning, but in general, I try to get through all of the comments. So yeah, do feel free to jump in at any point, ask questions, leave your comments. If you haven't done so yet, please do subscribe to the YouTube channel. It really does help boost engagement. Leave a comment, like the video, do all of the usual YouTube engagement things. It really does help, and I really do appreciate all of it. So press all of the buttons, make stuff happen. I also like pressing random buttons. You might have noticed we had different music today because I found a new music button. But at some point, I'm going to use the official Cup of Cosmology music for the opening. I just haven't figured that out yet, but that's also ongoing. That's actually one of my projects for when I have time, but I have no idea that when I have time is actually going to happen. But I have a list of projects. But at some point, we should go through them. Anyway, that was a random tangent that probably didn't make sense to most people, yeah. Spooky fact, water qualifies as lava because ice qualifies as a mineral rock. Yeah, that's a fun technicality, right? It's interesting how, like, can you really count water or ice as a rock or as a mineral? Well, technically, yes. Is water a liquid rock? Technically, yes. Does that make it lava? Also, technically correct. Is it actually correct? Well, yes. It's one of those things that where technically correct and factually correct just feel slightly like adults. But yes, technically you could classify water or ice as a rock and therefore water as lava if you feel so inclined. However, I don't think it would be helpful in everyday conversation if you say, I'm drinking a glass of lava. People might give you funny looks if you start doing that. On the other hand, then it could be more fun, Anyway, let's not go down that path. But yes, water, lava, tech on some kind of level could be considered to be similar, which is a fun fact as well, but not on my spooky fun fact list. I have a long list of spooky facts, so let's jump straight in. And as always, do feel free to jump in with your comments and your questions. And I just need to make a disclaimer at the start because this is Cup of Cosmology. The regulars know there's one thing we should always expect in Cup of Cosmology. So I just want to make the comment that today will not be about the CMB, the Cosmic Microwave Background Radiation. This will not feature today. However, you got to see it anyway. And at the conference I was at this week, I learned some really cool things about some future things that people are doing with CMB missions. And I'm super hyped about the CMB again, as opposed to when I'm usually only like medium hyped about the CMB. So it's quite likely that in one of my streams soon, I'm going to do a whole stream about CMB. I wonder if I can get that speaker on the stream. I'm going to do a whole CMB stream soon, but not today. Today, that's all we're going to see of the CMB today. Just had to show it, just, it had to make an appearance. I am speaking very quickly today. I'm not actually like on a sugar high or a caffeine high. I have been like for most of the week, but I'm currently actually not. I'm just hyper. Spooky season, spooky facts, let's go. So if I'm doing a stream about spooky things in space, I have to start with the obvious one. The obvious one that everyone says, but that is still very cool, which is that nobody can hear you scream in space. Space is extremely, ridiculously silent. There is no sound in space. The reason for this, official music of the channel should be slurp, slurp, slurp. Yeah, there is actually official music for Cup of Cosmology. It features in the trailer, and it was designed specifically for Cup of Cosmology. I commissioned a musician to do it. I just never use it. It's in the trailer, but otherwise, I hope you've all seen the Cup of Cosmology trailer. If not, please go to the YouTube channel and watch it because I put a lot of effort into that. Anyway, no one can hear you scream in space. You can also not hear anybody sneak up on you in space by the same logic. The reason for this is that sound is a pressure wave, which means it needs something to travel through. When you produce a noise, what happens is you vibrate the atoms. This vibration passes on. So kind of you vibrate one, it passes on, it passes on, it passes on. If there are no atoms to vibrate, the sound can't travel. The pressure wave can't propagate. If you imagine a line of dominoes, dominoes are close together, you knock one, it's going to have a chain reaction, they're all going to fall down. If your dominoes are really, really, really far apart, you knock down one and nothing is going to happen. This one won't fall. Just this one stays there. You're not going to get the domino reaction. So sound waves propagate in a similar way. If you have dominoes stacked very close together, or in this case, atoms very close together, you can create this pressure wave. If they're very far apart, sound is not going to travel. With some caveats, of course, that then if you have something where the atoms are really fixed, like in a nice dense structure, then sound is also not going to travel well because you can't pass the vibration. They're already kind of locked in a grid and they don't vibrate. That's why sound doesn't travel as well through solids as it does through liquids. But space is a vacuum. There is basically nothing in space. If you find any atoms, they are very, very, very far apart from each other, which means space is basically very, 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 very big and therefore very, very, very quiet. It is the quietest place we can imagine. So nobody would hear you scream in space. Also means that sci-fi shows, unfortunately, are not realistic for a lot of things. But you take any sci-fi show and you have the pew-pew laser fights and space battles and planets exploding, and yes, I'm talking very specifically about Star Wars. None of this would actually happen. You do not hear anything in space. This is something that Firefly did properly. They shoot a gun in space at some point and you do not hear it because it is the vacuum of space. So evolution needs to find a way to listen to electromagnetic waves, not just see them. That would be so creepy though, wouldn't it? Imagine if like every input was a sound, like everything. It would be fun. Incidentally, there are some people that can do that. Like there are some people who hear colors. It's called synesthesia. It's where some of your senses do something that is like crossed, and you can taste smells or you can hear sounds. Sorry, we can hear sound. You can hear colors or you can taste sounds, and this sounds like a superpower to me. Love that. But anyway, first spooky fact: space is very, 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 very silent. Incredibly silent. Your internet connection doesn't work well. That's my spooky thing just now. Yeah, the spookiness is spreading. It's a spooky action at a distance, which incidentally is not going to feature today. The quantum entanglement spooky action at a distance is not actually that spooky, and therefore is not part of the Halloween. But I did a whole stream on quantum entanglement, so if you want spooky action at a distance, please go watch quantum entanglement stream. It's pinned as one of the main videos. Okay. Fact number one, space is very, 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 very silent, which is cool. Nobody can hear you scream. Nobody can sneak up on, or people can sneak up on you because you wouldn't hear them coming. But this is just a warm-up one. Let's get into more fun space facts. So we know that even though the universe is very, very, very empty, it is also very full of stars and galaxies. Are you saying the Death Star is a lie? Right? Oh my God, Star Wars is not real? Wow. There are no midichlorians in our body giving us a force? Such a disappointment. I'm sorry. But okay, so the universe is very, very empty, but it is also full of stars and galaxies. When we look out at the night sky, we're used to seeing galaxies and stars. And if you consider all of your like Hubble deep field images, you see hundreds of stars and galaxies. Now imagine if you looked out and there was a part of space where nothing is looking back. No stars, no galaxies, just a big black void. And well, if you're wondering, like, is this a real thing? Yes, it is indeed. So there is a region of space, and I just pressed the button too many times. There's a region of space that looks like this. This is an actual image taken by the European Space Observatory, the European Southern Observatory. And there is this big black void. There is this cosmic void here, or what looks like a big black void. This is a real image. You have stars all around, and then you have this blob, this black blob. Now, when this image came out, this image is quite old now. It's been around for a few years. And when this image initially came out, a lot of people jumped on it like, oh my God, there's a hole in the universe. There is literally a hole in the universe. There's like this big black thing. What is this? And it's not even round, so you can't really say it's a black hole, it's a clump of dark matter. It's just this thing. But this fun, like creepy fact is actually to tell you that this is not a void. So I'm sorry if you think it is. I'm sorry if I led you to believe it is. If you've seen it in the media, it looks creepy. It looks spooky. It looks like a big black void of nothingness, but it actually is not. What is actually happening here is you have a cloud of gas. So in the intergalactic medium, you can have a lot of different stuff, including clouds of gas. These clouds of gas do not necessarily emit their own light. This big black region here is not a hole in the universe. It is actually a clump of dust blocking part of the universe. It does indeed look like a cloud in front of the stars because that's exactly what it is. It's a cloud of dust that doesn't emit light and blocks out a big chunk of stars. Now, this thing is wider than our whole galaxy, so it is a pretty big thing. And when this photo came out, and people were like, oh my God, this is like, what is this? It looks like a literal hole in the universe. But no, it is actually just a cloud in front of the stars. And you can see this, especially if you look around the edges, because you can see there are some stars that are still a bit visible, and others that are blocked. So even though it looks like a creepy hole in the universe, it is actually not a creepy hole in the universe. It is a cloud blocking some things. But then that leads to the next thought of like, okay, so if there are these big clouds that can block out billions and billions of stars, what if you live somewhere close by? You've lost the stream. Please do let me know if it comes back. Other people do let me know if you can still hear and see me. Hopefully you can. If not, you won't even hear me asking you to confirm that you can hear and see me. But hopefully you can all hear and see me. Please let me know if it's the case, if it's just on David's end, or I'm going to continue talking, assuming it's only on David's end. But if not, please do let me know. So yeah, imagine if you live somewhere near here, there's just like this big cloud. It's really, really, really cool. Okay, I see comments coming through, so I assume everything's going well. And as David Dunn is saying here, if you use it's back. Okay, so it did go offline for people here. Sorry about that. Not sure what happened. Glad stream is back. Sometimes there are issues. I realized I didn't plug in my Ethernet, so maybe the Wi-Fi just dropped out. All good here. It's bipping in and out. Okay. Might be some issues on somebody's end, but let's just continue. It's the spookiness of Halloween. It's just adding to it. You do have some kind of synesthesia. Some words, mostly names, remind me of foods. Wow, that is really, really cool. Personally, I think that is very cool. I can imagine that might not be cool if it reminds you of foods you don't like. But then it's like, do you? That must be so fun. Like, this person is pumpkin. I'm sorry, I find this fascinating. This is really, really interesting. Thank you for sharing that with us. That is very, very cool. Back in the old days when we were on Periscope or on HAPS, the neuroscientist Ian McLaughlin was doing streams. He did a whole stream about synesthesia, and it was so cool. So, as David Dunn is saying here in the comments, if you use infrared to look through this, you actually do see the stars on the other side. I don't have the infrared image pulled up here, but even though this big black cloud looks impenetrable, if you switch to infrared where you get different wavelengths, you can actually see through it. So even though this looks like a scary cosmic void, it is not. And I wanted to take this chance because if you look up scary space facts online, you always end up with this image and people saying there's a hole in the universe. No, there's not. It's a cloud. It is quite disappointing. However, this one is not a void, but there are regions in the universe where there are cosmic voids. So we know that the universe is clumped in kind of a cosmic web. So this is a simulation of what the universe looks like. Every glowing dot here represents a galaxy, and you can see the galaxies come together in this kind of cosmic web. Can't see stream on your end either. Well, that's very unfortunate. It seems like it's working for some people and not for others. Stream is only loading. Don't know if it's just me or a YouTube problem, but live streams aren't working great. So it's a problem at YouTube. Okay. And I guess the people watching on Twitter can see it fine. Okay, so sorry about that. Some issues. Can't really do much about this. We're just going to have to go with it and hope for the best. There's nothing I can change on my end that I know of that could improve this. So we just have to assume that it's going to be like some spookiness happening. Sorry for that. Let's just hope for the best and see what happens. But good to know it isn't just on my side. Okay. Looks like there might be a problem. Tried accessing via various devices. That's a bit annoying. It's okay again now. Other videos play fine, but this and other live videos are spending more time buffering than playing. Okay. It is working for me on YouTube, so it is very random. It's working for some people, not working for others. Let's just see what happens. So this here is a simulation of what our universe looks like. Every glowing dot represents a galaxy, and every dark region represents a void. Which means there are regions of the universe where there is nothing, where it's just the void. Everything clumps together following the gravitational force. So you get these regions where there's a lot of things and regions where there's nothing. So even though this image is not actually a real cosmic void, it's just a cloud, which is somewhat disappointing. There are actual cosmic voids out there. So there are regions of the universe where there is basically nothing. And that must be really scary. Imagine if you just, for whatever reason, happen to find yourself in a cosmic void. We're going to come back to this later. And you look out with a night sky and there's just literally nothing. Must be terrifying. Leave it trying in the background while you process some moth data. Moth data. That does sound cool. Your name is Dal, which is kind of lentil pulse. Okay, I'm confused by that, but okay. So yeah, my name is Dal. I'm confused by that. So, cosmic voids are a very, very cool thing. It must be terrifying to live in one, but a void by definition means there's nobody living there. And that brings me to the next thing I want to talk about. What's the opposite of a cosmic void? A place where you have a lot of stuff happening. So we know that our galaxy is part of a cluster of galaxies, and our cluster of galaxies is part of a supercluster of galaxies. Close by, we have the Virgo cluster. We're together in a local group of galaxies. But all of these galaxies are part of something bigger. They're part of a superstructure, which you've probably seen by now because it came out a few years ago with latest data. And yeah, I really should put my phone away because my phone buzzes and I pick it up to read messages. So phone has just gone away. Now I forgot to mute it this time. I normally do. So a couple of years ago, an image came out of like, this is the map of the universe. You are here. And it's this image here. This is a Laniakea. This is our local supercluster. Milky Way is highlighted here for ease. Now, this is not a real image. Oh, it's synesthesia thing. Sorry, I missed that and then didn't relate that. So my name is Dal. Okay, so I actually love Dal. So I'm very happy if you hear my name and taste the lentil, like a lentil dal, because that sounds like a very cool thing to me. So I'm happy with that. That is very, very cool. Cosmic party, opposite of cosmic void, exactly. So in a region, instead of cosmic void, in a region where you have a lot of things, you might have something like this supercluster. Supercluster where you have the Virgo supercluster somewhere here, you have the local group with us. This is an artist's rendition. This is not actually what it looks like, but our simulations are pretty close to this. Okay, so where's the spookiness here? Well, everything we know that galaxies in the universe are moving. The universe is expanding, galaxies are moving away from us. Someday we might look out into the night sky and see no galaxies because everything will be moved further and further away from us. But apart from the fact that everything is moving away from us, in this big supercluster, we are all being drawn to something known as the Great Attractor. The Great Attractor is kind of like at the center of Laniakea. And here's a cool thing. We have no idea what the Great Attractor is. We really have no idea. And the reason we have no idea is because it's hidden from us by our own galaxy. So our galaxy is very, very bright. And if you stare directly at the center of our galaxy, you can't really see anything behind it because you just see all of the stars and all of the light coming from our galaxy. So it's very hard to see beyond that. And the center of our galaxy just happens to lie exactly in our line of sight with this Great Attractor. So we know that based on how galaxies move, it seems like everything in Laniakea is being drawn to something. And we have no idea what this something is. Tried to reboot PC, but no success. Zombies on the line? Yeah, must be zombies. I'm going to blame YouTube and say zombies on YouTube side, but for some people it's working. So I don't really know how to fix that, I'm afraid, if it's working for some and not for others. I'm wondering, and if people can please confirm, I think it might be related to having the images up. So can people who are having issues, let me know if you have more issues when I have images up, because it might be that adds a lot of buffering to the stream. But yeah, if that's the case, I just don't show more images, that's fine. So there is something big, massive, that is so big and massive that it is drawing 100,000 galaxies towards it. All of the galaxies in Laniakea, which is between 100,000 and 150,000, are being drawn to something. And we can't see what this something is because our galaxy blocks it, which personally I find to be very scary. Now, there are likely explanations. It is probably something like a big cluster, a big mass region, maybe dark matter, maybe some big galaxies. It's probably something like this. But we don't know because it is hidden from us. So we are all being drawn to this big region in the universe. 100,000 galaxies are all being drawn to this region. And we're not entirely sure what is there or why we're drawn to it. We're drawn to it gravitational force, okay, sure. What is causing this gravitational force? What is pulling us in? We don't know, and we might never know. So that's fun. There is something out there, the Great Attractor, as we like to call it, that is just pulling us in and pulling us in and pulling us in. And we don't know what it is. But I'm sure it's going to be perfectly fine. What's the worst that could happen? Famous last words. But I think Laniakea and the Great Attractor are really, really, really cool. Yeah, we also won't know what it's there for any time. It's not like we're going to be able to solve this mystery because our galaxy's in the way. It's the middle of land. Yeah, the Great Attractor is in the middle of Laniakea. What it is, it's the middle of Laniakea. If you're happy with that answer, great. If not, well. Okay, so that's like a big scary thing that's pulling the galaxy, but it's a bit kind of obscure and far away. And you may or may not be okay with Laniakea just pulling us in, being drawn in by something. So let's move on to something else. I bet 10 euros it's just a massive galaxy. Take note of the fact that I bet only 10 euros. It's a localized big crunch. I love the comments and the hypothesis. Is it a big crunch? What's going to happen when all these galaxies get there? I mean, it's going to take us a while because this is a big chunk of universe we're talking about. But what would happen? Are we all going to crash? Are we going to converge on one point? What's going to happen? We don't know. It just so happens that our galaxy is a bit inconveniently positioned. And yes, I wouldn't make more than a 10 euro bet on this, but it's probably just a region of a lot of galaxies. Probably nothing to be concerned about. What could possibly go wrong? So I want to talk about, I'm going to change topics now, and I'm going to move on to some random things inside the universe. And I'm going to start small, go big, and then bring it back to small, and then go big again, because I did not plan how I was going to go through these things. I just wrote 10 facts down. I planned the first one and the last one, and how we get through the others was not completely planned, because I literally started planning this 2.5 hours ago because I was distracted booking flights and looking at outfits for a wedding. So next thing I want to talk about, which was teased in, if you saw the announcement on Twitter, on Mastodon, or even in the YouTube description, I mentioned vampire stars. And vampire stars, of course, need to feature in a Halloween stream. So what are vampire stars? Vampire stars are actually a thing that we're pretty sure exists. In fact, we know they exist. We've seen them. So we know that a lot of stars don't exist by themselves. They're locked in either binary or trinary systems, where you have 2 stars or 3 stars orbiting around each other. This is actually the most common configuration, 2 stars orbiting around each other, locked. If these stars happen to be neutron stars or black holes, you can have mergers, you can produce gravitational waves. How long till the Milky Way reaches the Great Attractor? A couple billion years, at least. It's not something we have to worry about anytime soon. It's going to be a couple billion years away. But, it will happen eventually, but no time soon. CMB dress for the wedding would be very, very cool idea, actually. I could get someone to make me a CMB dress. Yeah, that would cover yellow and blue. Yeah, that could be fun. But no, I've already figured out my wedding outfits, and it does not involve CMB. I would not worry about the Great Attractor. We will be long dead before anything happens. That is the type of optimism I hope you'll take away from here. Doesn't matter, world's on fire anyway, and we're going to be long dead before we reach the Great Attractor. So let's not worry about what this big mysterious thing drawing us in is, because we'll be long dead by the time it reaches us. Love that mentality. So, vampire stars. What are vampire stars? I was saying that you can have 2 stars. In fact, it is very common to have 2 stars locked in a binary orbit. Now, we know that this happens frequently in the universe. We've seen neutron stars, we've seen black holes colliding. But there can be a configuration where you have a white dwarf and another star. And they're close enough that the white dwarf, the white dwarf is kind of like a star that's reached the end of its life and collapsed, and it's just using up the last bits of its fuel by now. But this white star, I'm not the one getting married. I'm going to somebody else's wedding. I absolutely know what I would wear to my own wedding already. But no, I'm going to somebody else's wedding, and I'm planning outfits. It's actually going to be a wedding in India, and I'm planning a lot of outfits, and I'm really excited. But that's basically what distracted me from preparing the stream earlier today. But the congratulations are not towards me. It is very much not my wedding. So if we hit the Great Attractor before we collide with Andromeda, I'm not actually sure. I think the collision with Andromeda comes first, and then the collision into the Great Attractor. So first of all, we're going to merge with Andromeda, because another cool fact that the galaxy closest to us is heading towards us on a collision course. So that's fun. Probably going to be perfectly harmless, but it is going to happen at some point. Okay, binary stars. You have a white dwarf, you have another star. If they're close enough, the white dwarf can actually start sucking away mass from the other star. So you get one star that starts as quite a small star. This white dwarf is quite small, and another star. And the white dwarf can actually have such a strong gravitational pull that it can start ripping away mass from the other star. So you get the white dwarf, and it just that star looks good, and just start sucking away the mass, sucking away the outer layers of the other star. These outer layers are then going to form an accretion disk. So you have your star. Let's just pretend this is a star for now. This is my little white dwarf. It's not a white dwarf, but let's just pretend this is my white dwarf. And there's another star here. The white dwarf is gradually going to suck in the other star and form this accretion disk. So a disk around it where all of the matter is accumulating. So you have white dwarf, and this accretion disk is literally the body of the other star that it's sucking in and ripping up. And this is a real thing that we know is out there. So this vampire star, this white dwarf, is using the mass of the other star to sustain itself. So it's pulling it in, and it's pulling it in, and gradually destroying the donor star, as they're called, in a very fun way. It pulls it in and gradually just like creates its own accretion disk. Eventually, the donor star is going to be small enough that it is either going to collapse or go supernova as well. If it can eject its outer layers, it could go supernova. But what's more likely to happen is it's gradually going to get smaller and smaller and smaller while the vampire white dwarf is sucking up all of its energy. And then once this white dwarf has its accretion disk, if enough mass falls on the white dwarf, it can actually trigger a supernova event and take out both stars. So basically, this white dwarf vampire star is going to eat until it's so full it explodes and kills both the victim and itself. So that's pretty cool. And this is why they're called vampire stars. And we have actually observed some of these in the Milky Way. We know this is a thing. We have seen pairs of a vampire star and a donor star, where the vampire star is literally slowly sucking away energy from the other star. And this is not to be confused with cannibal stars, which are another type of star that are just so big they directly absorb the other one. So you can also have cannibal stars in binary systems. You have two stars, and one of them is just like, that's a tasty snack, and just eats the other star, just sucks it up in one go. So I guess it's a difference of if you want a slow death or a quick death. Cannibal stars will kill the other star quickly. Vampire stars will suck out the energy in a slow and gradual process. So that's fun. Not something we need to worry about ourselves, but very cool to think about the fact that there are vampire stars and cannibal stars out there. Lots of new stars form on the large scale, though, yes. Yeah, so when two galaxies crash together, not much is going to happen. Most of them are going to pass through unhindered. Most of them. There might be some stars that come close enough that they can disrupt each other. But overall, when two galaxies merge together, most things are going to pass by unnoticed because galaxies are mostly empty space. However, you can have fun gravitational disruptions, which we're going to come back to later again. You can have regions where stars come close enough to each other that they can disrupt each other, which is very cool to think about. So, vampire stars, cannibal stars, not really scary to our day-to-day existence, but something that I felt like just had to feature in a Halloween stream because it's vampire stars. But going on to something else that can affect us, black holes. Of course, if I'm doing the spooky stream, I have to talk about black holes. Mainly because black holes are one of the things that a lot of people think is one of the scariest things in the universe. And I don't think black holes are one of the scariest things in the universe to some degree. So a black hole is a region of space-time that is so dense that nothing can escape, not even light. You'd need to travel faster than light in a vacuum to escape the gravitational pull of a black hole. As far as we know, nothing in the universe can travel faster than light in a vacuum, and therefore nothing can escape the gravitational pull of a black hole. It means a black hole is basically the end point of the universe. Not of the universe, but of things inside the universe. Once you get close enough to a black hole, there is no escape. And once you fall into a black hole, you are never coming back. So a black hole really is like, if you're in a bath and you pull out the plug and all the water goes down the drain, it's like that, but in the universe. Anything close enough is going to go there eventually. The good thing is that black holes are governed by the gravitational force, and the gravitational force is very weak. So the further you get away from a black hole, the less you feel its force, because gravitational force decreases with distance squared. So if you increase your distance to a black hole by a factor 10, the gravitational force decreases by a factor 100. Which means, the good thing to do with black holes is just don't get too close to them. Just avoid them. If you get close, it will kill you. It will do spaghettification. It will tear your body apart. It can freeze you in time on the event horizon. Just don't go close. If you know a black hole, just don't go there. Avoid that place. Which would be nice, right? Except black holes are way too prevalent. In fact, there is a supermassive black hole at the center of every galaxy. As the name implies, a supermassive black hole is a black hole that is kind of big. And by kind of big, I mean like billions of times the mass of the sun. A normal black hole, if you can think of these cosmic drain pipes as being normal, a normal black hole is like about 5 times the mass of the sun, 30 times the mass of the sun, maybe 100, depending on how you make it. Supermassive black holes are billions of times the mass of the sun. And there is one at the center of every single galaxy. Supermassive black holes are, as the name implies, massive. They do help us stabilize galaxies, so without supermassive black holes, we're not really sure if galaxies would have the same structure, so they are kind of useful. But they're there. But see, the thing about supermassive black holes is it's at the center of the galaxy. It's there. Just don't go to the center of the galaxy, you're going to be okay. But what about all of the black holes in our universe? Now, we know that there are thousands of black holes in our universe, and thousands and thousands and thousands just within the Milky Way. These are the ones that we've detected in LIGO, where black holes come together, they merge, they produce gravitational waves. We found these gravitational waves with LIGO, Virgo, and Calgary. Within 5 years of finding the first one, we found over 100 events. If we found over 100 collisions of black holes in a few years that we've been looking, that means that there are a lot of them colliding within our galaxy. And that means there's a lot of them out there that are also not colliding. But the most common type of black hole to think of is a star that's reached the end of its lifetime and collapses. Now, the good things about stars is they're kind of gravitationally bound within galaxies. They follow more or less the overall trends. They move around the galaxy. They're kind of like on a clear path. But what happens if a black hole is not gravitationally bound to anything else? What happens if you get a rogue black hole? So we know that there can be rogue stars. There can be rogue planets even. So a rogue star is a star that at some point was doing its own thing in the galaxy, and then it got disrupted from its orbit and got shot out throughout the universe. And it's might even travel from one galaxy to another. It's just a star that's doing its own thing. It got slingshot out of the galaxy or out of its place, and it's just going on a completely random trajectory. We're pretty sure stars can do this. We're also pretty sure planets can do this. Black holes could also do this. So imagine you have a star, collapses, turns into a black hole. Okay, it's doing its own thing. But then another star comes close by enough to dislodge it. And suddenly, you have a black hole just spiraling throughout the galaxy. Now, the thing about black holes is they suck everything in. They do not emit any type of light, which means the only way you can see a black hole is by how it's disturbing other things, by the gravitational effect it has on everything else. So if you have a massive black hole that is just traveling throughout the galaxy, doing its own thing, could it be on a collision course with Earth? Well, it could be. Would we see it coming? Absolutely not. So that's a fun thing to think about. Rogue black holes, just black holes traveling throughout the universe, maybe going from one galaxy to another, just doing their own thing, minding their own business. Good thing about a black hole, stay away from it. You're good. Don't get close. What if the black hole gets close to you? What if the black hole sneaks up on you? You're not going to hear it coming. We've established that. And you're not going to see it coming because it's a black hole. Will I be online next week? I believe I will be, unless there's something that I'm misremembering. I should be online next week. Thanks for stopping by, David. So, yeah, black holes, great. Leave them alone. What if the black hole's chasing you? What do you do then? Well, we just assume that it's not, again, going back to the idea that space is very, very, very empty. So the chances of us being hit by a rogue black hole are quite small, but they're not zero. And I just mentioned, apart from rogue black holes, I just made the offhand comment of rogue planets. I want to take a minute and talk about rogue planets because it's a really cool idea and it ties into something we were saying just now. So most planets, in fact, all planets that we know of at some point are bound to a star. Like we have a planet orbiting around a star. Now, what would happen if Something disrupted our orbit. Something, for an example, when Andromeda and Milky Way crash together and you've got stars passing each other by, of course, most of them are not going to collide. But if a star just comes close enough to disrupt the delicate balance of our orbit around the sun, we could be dislodged. And if this happens, we could become a rogue star, a rogue planet, a planet that is no longer gravitationally bound to its star and that just travels and its own thing, doing its own thing. So what would happen, hypothetically speaking? What would happen if something massive and disruptive came and dislodged us from our orbit around the Earth? Well, first thing that would happen is we would gradually get colder and colder. So we'd see our sun getting further and further away, gradually losing light. So it's gradually going to get colder and darker. We're not going to have any energy source external to us. And we will gradually lose sight of the night sky that we know. The planets that we know will fade away. The stars that we know will fade away. The night sky will look very different. And you'll gradually get colder and colder and colder and darker as we move away from things. Now, if it reaches the point where we're dislodged so much that we could even leave the Milky Way, which there are reasons to believe that some rogue planets could do this, stars would start to fade. You'd move into the kind of intergalactic medium where stars are so far away that you would stop seeing most of them. Most of the things we see in the night sky are within the Milky Way. If we got dislodged so much that we got kicked out of the Milky Way, the sky would go dark. Like during the day, because the sun is gone, there would be no more day night, but you wouldn't see stars either. Of course, you'd all freeze to death long before that happens. So, even though it's quite unlikely, there are some things that could disrupt us from our orbit. And then we go back to the thing I mentioned earlier of like if you lived in a cloud and you looked out and you couldn't see anything, if you're in a cosmic void, how must that feel? What if you get dislodged from your orbit so much that you actually go out into the void? Now, of course, we wouldn't survive it. We'd be dead by so many levels. But anything that came to Earth in the future would just see a chunk of rock floating lifelessly through the universe with no contact with its star. So, black holes, somewhat scary. Rogue black holes, very scary in my opinion. The prospect of becoming a rogue planet, very scary, but also very unlikely. So we probably don't need to worry about going off on a road trip away from our star, but it's a possibility. So, black holes can kill you if you get close enough. Stay away from them. Black holes can come find you. Rogue black holes, fun. And there are some things like collisions of galaxies, like stars flying close by, like a supermassive black hole coming close to us, like galaxies colliding, supernovas dislodging us. All of these things could potentially eject the sun from the solar system. However, it is very, very, very unlikely. There's many other ways the universe can kill you that are more likely. For an example, asteroids. Asteroids is probably the easiest way the universe can kill us. So we know that the universe is full of rocks. Some of them are big enough to form planets, most of them are not. There's hundreds of asteroids out there. There's asteroid belts in the Milky Way, 2 of them, in fact. There's one close and one far away. There are asteroid belts in the Milky Way. So we know there are many, many different asteroids and chunks of rock out there in the universe. We also know that occasionally chunks of rock can actually hit the Earth. We know that this happens a lot more frequently than... It happens quite frequently. Not just to our planet. If you look at the surface of the moon, it's covered in craters from when it was hit by space rocks. Asteroids that then come close become meteors and meteorites and smash down onto the planet or the moon. Now we have the nice protection, that is the ozone layer, the atmosphere, that is protecting us. We have an atmosphere that protects us from a lot of space rocks. They come down, they burn up in our atmosphere, and therefore they don't have a big impact. But if you look at the moon, where there's very little atmosphere, or even something like Venus, Mars, these are bombarded constantly by rocks. Jupiter is our friend in this case. Jupiter is a big planet out there that is bigger than us, and it gravitationally pulls all the rocks towards it. So Jupiter actually saves us from many asteroids. But some still do hit. And we've already seen that asteroids can be pretty catastrophic. If asteroids come in many shapes and sizes, and if they're big enough, they can actually cause a lot of damage. We know that some asteroids actually make it to Earth. There's been some over the last few years that have caused different levels of damage. In the best case scenario, you just see the fireball, your windows break, you're done. But asteroids can be pretty catastrophic depending on how fast they come and how big they are. And we know that an asteroid was responsible for taking out the dinosaurs and a lot of the mammal species that lived on Earth back in those days. So we know a big asteroid has hit Earth before. And in the famous words of Armageddon, it's only a matter of question. The question is when. Now, Armageddon is not a film anyone should ever cite in any type of scientific context. However, the fact that an asteroid has hit us before it can happen again, this is true. Space is very, 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 very big, and it is very difficult to monitor. Now, the good thing is asteroids that would be destructive are pretty big. Bigger things are easier to find. So the asteroids that could cause cataclysmic events within the solar system, we pretty much have a good understanding of. We know where they are. Not all of them, but we've mapped most of them out. The smaller ones we'll never see coming, but the smaller ones are less destructive. So it's quite likely that if there is a dinosaur scale asteroid coming to wipe us out, we would probably see it coming, but not necessarily, because again, space is very, very big. And even though we have most of the big ones mapped out, there can be, in the same way you can have rogue planets and rogue black holes and rogue stars, you can have rogue space rocks. And if you have a rogue space rock, it might be very difficult to map this until it's on a collision course with us. So an asteroid could potentially wipe out all of life on Earth, depending where it hits. There's actually a fun web page that is like asteroid simulator, and you can set the size and the speed of the asteroid and which city you want it to hit, and you let your asteroid go, and then it tells you the effect on the population and like how much of Earth is wiped out and what happens and how. It's so cool. If you Google like asteroid simulator, you'll find it. If you feel like throwing asteroids at people's houses, please use the simulator. Don't actually, control an asteroid. So what would we do if an asteroid were heading towards us? Well, that's a good question. People are working on it. There's the idea that NASA launched a mission a few years ago called DART, which just moved an asteroid. It crashed into an asteroid enough to dislodge it, and it was pretty successful. So there are methods like defense asteroid removal technique or something like that, the DART mission, and it just kind of nudged the asteroid out of the way. And it worked on a very small rock that they were testing it on. If an asteroid is big enough to cause cataclysmic damage to Earth, would we be able to move it out of the way is a good question. So while asteroids are not likely to kill us all, they could. And it is probably more likely to be killed by an asteroid than by a rogue black hole, or then the Earth becoming a rogue planet. So asteroids are a big point of concern, but we're not overly worried about it happening anytime soon. So if an asteroid's not going to take us out, or it might not, what is going to take us out? And now I want to move into gamma ray bursts. So imagine if you could take 100 million stars, 100 million light years away from us, take all the stars in this region, take all of their energy and condense it into one massive super weapon. This actually exists. These are called gamma ray bursts. So a gamma ray burst is, as the name implies, a burst of gamma rays. Gamma rays are just normal photons that are very, very energetic. So they're particles of light that are very energetic. We know the electromagnetic spectrum is indeed a spectrum of electromagnetic waves. You can have the low energy ones like radio waves and microwaves. You have the visible one, and then you have the high energy ones, the ultraviolets and the gamma rays. So gamma rays are just extremely energetic particles of light. But a gamma ray is so energetic, it is what is known as ionizing radiation. If a gamma ray hits you directly, it can actually dislodge the electrons that are bound up in your atoms, which means it can cause a lot of damage to your atoms and therefore to your cells. It will not turn you into the Hulk, I'm afraid, but gamma rays are dangerous. We should not be hit by gamma rays too much. Good thing is we have our atmosphere protecting us. Our atmosphere does actually protect us from a lot of gamma ray bursts. but we know that gamma ray bursts do happen in the universe. Sorry, our atmosphere protects us from gamma rays in general. But what about a burst of high energy gamma rays concentrated? So this is what you get with a gamma ray burst. So a gamma ray burst is, as the name implies, just a really big burst of energy. And we've seen them. I just lost the entire chat window. This is weird. Okay, I think my whole restream is just frozen now. Okay, back now. I just lost the whole chat window, just disappeared. I have the chat window up here. I can show you all the chat window as well. See, there is a chat window. It should be over there now. But for some reason, it just disappeared. It's back now. I can put it on screen, but I assume nobody needs to see the chat window except me, because you can all see it in YouTube anyway. So we've seen gamma ray bursts in the universe. The one we've seen was 6 billion light years away. 6 billion light years, which means it came from a whole other galaxy. Now, in order for us to see something that was I can see your message. I see a message saying test, so I do see the message. Thank you for testing that. So in order for us to see something that came from 6 billion light years away, 6 billion light years, happened 6 billion years ago, and it took 6 billion years for the light to reach us. In order for us to see this, it has to be ridiculously bright. So bright that in the 1 second that a gamma ray burst can last, it releases more energy than the sun does over its 9 million years of life. 9 billion years of life, sorry. So over the entire, if you take the entire energy output of the sun over its entire life and you condense it into 1 second, that's the amount of energy you get in a gamma ray burst. It is a ridiculous amount of energy. There are two types of gamma ray bursts, as far as we know. There's the long gamma ray burst, which is long, they last about a minute, and they happen when in a supernova, core collapses, pushes everything outwards. You get a supernova together with a gamma ray burst. These are the long ones, they last about 1 minute. Then you have short gamma ray bursts, they last about a second, and it's what you get when you have two neutron stars merging together. Now, in both of these scenarios, what is left behind is a black hole. A black hole that also has a magnetized disk of gas around it. So it has gas around the black hole that has a strong magnetic field. If you have a black hole with a strong enough magnetic field, this is going to create the magnetic lines are going to turn around the black hole is rotating, magnetic lines turn around. This creates a funnel, both on the top and the bottom of the star. This is a funnel where any high energy particle can get accelerated by the magnetic field and end up in this funnel. This funnel then spits out gamma rays. So you have any type of particle of light or any type of matter, for that matter, coming in to the black hole, getting caught up in the magnetic fields, getting attracted into the two jets and getting expelled in one of the two jets. So once you have your collapsed black hole, it's going to look something like this, with a jet pointing in each direction. These jets are going to be sending out gamma ray bursts, very, very, very high energy. Now, one bad thing about gamma ray bursts is they stay focused. So most light in the universe disperses. But because of the way they're created in the magnetic field, the gamma rays from a gamma ray burst stay focused, which means they can travel very far and keep their high energy. So then you have a highly focused energetic beam shooting out. The good thing is that means they're highly focused into a small region. So as long as it's not pointing towards you, you're fine. However, all of the ones we've seen so far have been outside of the Milky Way, which means they're pretty harmless. And we actually kind of detect about 1 gamma ray burst a day on average by now. This is synchrotron radiation. It is a type of synchrotron radiation. Yes, you accelerate the particles in the magnetic field, but if you do that and end up with gamma rays, you can end up with a burst of gamma rays. So the star goes into a black hole, it collapses into a black hole, you get this magnetic field. All of the matter that is around, for an example, from the supernova explosion, gets caught up and shot out. If you have photons doing this, you get gamma rays. So it's going to be a very narrow but very focused jet, which means, if we're over here, the jet could pass us by unless it's pointing exactly at us. The good thing is it means it's less likely to hit us because it needs to be very focused. The bad thing is if it hits us, it is extremely disruptive. So we've measured a lot of gamma ray bursts by now. All of the ones we've seen have been outside of the Milky Way. However, if you had one in the Milky Way it could be extremely disruptive. If you have one that is just like a few light years away, it would literally ignite our atmosphere. If you have a gamma ray that is like 5, 6, something like that light years away, if it's pointing towards us, it would ignite our atmosphere, or our atmosphere would go up in flames, which of course would be pretty damaging for the planets. So yeah, if a gamma ray burst is a couple of light years away from us, it would wipe out life on Earth. However, even if a gamma ray burst is a bit further away, let's say it's a few thousand light years away, if it's a few thousand light years away but still pointed at us, it would strip our atmosphere. It would wash over Earth and our Milky Way like a tidal wave. It would strip our atmosphere. It wouldn't directly kill us, it would just remove our atmosphere and leave the sun to kill us. So even a gamma ray burst that is the other side of the galaxy, if it's pointing towards us, straight towards us, it could burn our atmosphere, it could destroy our atmosphere. In both scenarios, in one we burn alive, in the other the sun cooks us, so we burn alive. It's just much slower. So you either instantly burn, or you gradually burn as our atmosphere is depleted and we can no longer protect ourselves against the sun. The good thing is that this is unlikely, because you need one that is close enough, big enough, and pointing towards us. So it's quite unlikely, but it might have happened before, and it might happen again. So we know that 450 million years ago, about 85% of all marine species were eradicated. We don't know why, but it could have been a gamma ray burst. There's no way to confirm or deny it, but it is one of the hypotheses. There's also the idea that gamma ray bursts could be the reason that the universe looks so empty. Because if you have a galaxy that is prone to gamma ray bursts, it would be very difficult to have life for a long period of time. Imagine if even just 1% of the stars in a galaxy turned into a gamma ray burst. No place would be safe. So that galaxy would be inhospitable. So there is the idea that if gamma ray bursts are as prevalent as we think they are, it could be that only 10% of the galaxies are actually habitable, because the rest of them just have too many gamma ray bursts for them to actually be useful. The page just keeps buffering. Yeah, I really don't know what to do about that. Sorry about the issues here. Other page is playing fine, just this one. Well, that's a shame. I really don't know what to do about the technical issues, I'm afraid. It's just spooky ghosts in the system. So yeah, gamma ray bursts could be responsible for the fact that we don't see much life in the universe, which is terrifying. But we think it's unlikely. Gamma ray bursts are not that common. We haven't seen any in our solar system yet. We have no reason to believe it is going to happen. If it did happen, we think our type of galaxy would have one every 10,000 to 1 million years, so it could happen at some point, but you'd need it pointing right towards you. Now, the fun thing is, if a gamma ray burst does happen and is pointing towards you, you would have literally no warning. We would not see it coming because it travels at the speed of light. When it hits you, it already hits you. So, as soon as it hits you, you're done. It's not like you can see it coming. It hits you, that's it. Atmosphere is gone, we're on fire. So if a gamma ray burst were to happen in the solar system, in the solar system would be devastating. If it were to happen in our galaxy, it's probably not going to be pointing towards us, but if it is, it's going to be catastrophic. So we probably don't need to worry about it, except there is a potential gamma ray burst candidate within the Milky Way. Not within the Milky Way. Yes, within the Milky Way. I'm mixing up Milky Way and solar system now. So there is a star known as Wolf-Rayet 104, which is about 8,000 light years away. It is a star that is currently burning its helium, which means it is going to go supernova at some point. It might be big enough to produce a gamma ray burst. Depending on who you believe, there may be a chance it is pointing somewhat in our direction. So Wolf-Rayet 104 is a star that is within the Milky Way. It's a star that is going to go supernova. It's probably not going to happen, but it might produce a gamma ray burst, and it might be pointing towards us. And if these two criteria are fulfilled, it would wipe out life on Earth. But it's probably not going to happen. I hope that's somewhat reassuring. So I think the coolest way, or one of the most scariest ways that the universe could kill us at any point, is with a gamma ray burst. But it's, again, not likely. It needs to be pointed towards us, and we need to be within its line of sight. It needs to happen close enough to actually be a problem. Lots of ifs, lots of maybes, probably not going to happen. But if you want something new to worry about, I would recommend worrying about gamma ray bursts. There's nothing you can do. You would not see it coming. It's not like we can prevent it in any way, or even know that it's going to happen definitively. Just at some point, we could just be wiped out. But if you want a different scenario that is still like catastrophic for us, but not as catastrophic, we don't even need to go as far away as the other side of the galaxy, to like WR 104. We can look within our own solar system. There's something that could be catastrophic to life as we know it. It wouldn't be like a life-ending event, but it could be catastrophic. And this is solar storms. So we know that our star is very, very active. We're going to go past the 1 hour mark today. It's fine. I still have another like 10, 15 minutes because we haven't yet got to my favorite one. That's saving that for last. So still going to be here 10, 15 minutes today. Solar storms are something that is happening constantly. Our star is very, very active. It goes through periods of activity and less activity. But when our star is active, it has daily solar storms. These result in things like solar flares or coronal mass ejections. This is happening pretty frequently. And it's just a star doing its own thing, sending stuff out in different directions. Bits of plasma, bits of ionizing radiation, fun stuff like that. Solar storms are responsible for cool things like the Northern Lights or the Southern Lights, the Aurora Borealis, which we get to see in Helsinki sometimes, which is absolutely amazing. So, overall it's not too bad, but a solar storm carries with it a strong magnetic field. If this hits Earth, or when this hits Earth, depending on the circumstances, and like if it's pointed directly towards us and so on, it can disrupt the magnetic field of the Earth. It kind of shifts it. You imagine the sun is here, Earth is here. Earth has a magnetic field around it. As the solar storm hits, the magnetic field just kind of wobbles a bit, shakes a bit, goes one way and then resets like. When this happens, if this happens, it could substantially disrupt communications on Earth to the point that it could wipe out our entire electricity grid. If a solar storm is strong enough or powerful enough or pointing in the right direction and meets a few criteria, it could literally wipe out the entire electric network of the planet. We know some similar things have happened before. 150 years ago, not long after the invention of the telegraph, there was actually a solar storm that wiped out all of the network for a day or two, and it was very disruptive. But at the time, they weren't so reliant on electricity. But just imagine what would happen if we had a 2-week-long worldwide power cut. It would completely affect our way of life. It would be very catastrophic in some ways. A lot of terrible things would happen. It wouldn't wipe out life on Earth, but it would definitely make us have to reset some things. And here's a fun fact. Moving away from space slightly, the entire European electrical grid could actually be taken out pretty easily. So there is even like plans in place of what would happen if we had a 2-week-long blackout, because it's not a completely unreasonable possibility. The American grid is the same, by the way. So it would be surprisingly easy, like some key infrastructure that if it were taken out by a coronal mass ejection could actually like knock off the grid for more than a day or two. And this is something that could happen. The sun is very active. The sun has solar storms. The good thing is we're getting very good at modeling said solar storms. Now with all of the satellites we have observing out there, we're getting pretty good at figuring out when solar storms are going to happen. That's how you get forecasts of, hey, there might be northern lights tomorrow, because we're getting pretty good at figuring out storms. However, a kind of like earth-altering storm that would be dramatic enough to wipe out communications, it's quite hard to predict when, if that's going to happen. Current estimates from NASA, actually from a couple of weeks ago, say that we would probably be able to detect this with like 1 hour warning, maybe half an hour warning if we're lucky. So imagine I suddenly tell you in half an hour you're going to lose the entire electricity network for 2 weeks. You have half an hour to prepare, go. What do you do? I am not ready for this eventuality. I don't think many of us are ready for this eventuality. This is why not this, but technically, according to a lot of countries and the governments of a lot of countries, you should have supplies in your home to last like 2 weeks, 2 weeks of food and water and stuff, medicine and everything you need. That was very unlikely to happen. But we don't need to think about other side of the galaxy is going to kill us, because a solar storm will be pretty disruptive. Probably not going to kill us, not going to wipe us out, not going to end life on Earth, but it would be pretty disruptive. There was a sci-fi film that did that, and I'm trying to think which one it was. Was it a Will Smith one? I remember there was a sci-fi film where the premise was a solar storm was taking out the entire electricity grid on Earth, and I can't remember which one it was. I know I watched it. It obviously did not leave a lasting impression if I don't remember much of it. Yeah, my chat box has disappeared again. This is weird. Okay, so we've gone through several space facts, or spooky facts about space. We've covered the fact that there is no sound in space. We've covered the cosmic void, the great attractor, vampire stars, black holes, rogue planets, asteroids, gamma ray bursts, solar storms. And now we get to my favorite one. All of these things that I mentioned are things within the universe. They are things in a galaxy. They're objects. They're specific phenomena. But what if the universe itself just turns off, or just decides, to wipe out the entire existence of the universe? Now, obviously, the universe, to our knowledge, is not a sentient being that can make this decision. But we know that the universe is governed by fields. Fields is basically like something that tells you, if you measure its value everywhere, you get a different value. Like temperature in the room, you measure the temperature in this room at every point, you get a different value. This is a field. It's not a specific thing, it's a field. It's true. Another thing to think about in the universe is the universe does not like spending energy when it doesn't have to. Everything has different energy levels, and things like to be in their lowest possible energy state. Similar to how on a Sunday we all like to be doing literally nothing because it is our lowest energy state. The universe, or things in the universe, always tend to be at their lowest possible energy state. This is true also for fields. Now imagine you have a field that's in its minimum, it's at its lowest energy state, it's happy there. But then it turns out this is not actually a true minimum, but a false minimum. You could have a field that looks something, that was a very bad drawing. Let me just redraw my field here. I just drew a line, and I literally had to draw one line, and I somehow managed to mess it up. So imagine that you have a field that looks something like this. This here. And am I thinking of the movie Knowing? That doesn't sound like a familiar title, so I'm going to say no, but maybe. So we have a minimum here and an actual minimum down here. So imagine the field is currently here. It's happy here. It's doing its own thing. It thinks it's at its minimum energy level. But then you have random quantum fluctuations in the universe, which can happen. And this field goes down there. It can tunnel to its lower state. Once that happens, once it gets over this, it is going to quickly, very, very quickly, fall to its new state. So you start here, the field is happy, it's like, I'm at my lowest energy level, and then it's on the which I can go down here. It is going to fall down there. So why is this relevant? Because if you have a field that is in its metastable state, when it tunnels to its new state, this is going to spread throughout the universe. It's not going to happen in one place. It is going to happen everywhere, because suddenly the universe is aware of the fact that there is this lowest energy level, this lowest vacuum state. So it could tunnel down. Now, if this happened, these fields are what give the universe its properties. So if you have, for an example, this energy field, that it's doing its own thing here, and then it tunnels down to a lower energy level, this potential suddenly tunnels down. This is going, the new energy level, the lowest ground state, is going to be different to the one it was on before. If this happens just somewhere in the universe, it is going to gradually spread. So what would happen is you get a pocket expanding, you get a pocket of the new field, the new lowest energy level. This is going to gradually expand and expand and expand. Everything it touches is suddenly going to be like, oh, wait, there's a low energy level there. I'm going to join it. And this is what causes it to expand, is everywhere in the universe gradually realizing, like, wait, I can go down here as well. So these bubbles would expand. Now, inside this bubble, the properties of the universe would be vastly different. It might even be that inside this bubble universe, life cannot exist. Life wouldn't not exist in any form in there. There might be no way where in this new version of the universe you could have an existence. And this bubble is going to if it happens anywhere, this bubble would expand and expand and expand and gradually pull the whole universe down with it. So it would basically be an expanding ball of death, because this bubble would be expanding and expanding and expanding, and everything it touches completely stops existing in its current format. It's not just like it's destroyed, it's just like it cannot exist in the new version of the universe. This bubble would expand at the speed of light, which means you would never see it coming. If there really were an expanding bubble, this expanding bubble of death in the universe, you would never see it coming. It could literally hit you at any point and you would never see it coming. And it will eventually take over the entire universe, because the universe likes being in its lowest energy state. So as this happens, the universe is going to be like, hey, lower energy, I'm going down there. We would not see it coming. We would not be able to prevent it. There's literally nothing you could do. And the whole universe would just change completely into a completely different state. And this is known as vacuum decay, or vacuum death, or expanding bubble of doom, depending on your perspective. And it would literally be this bubble expanding throughout the universe, wiping out everything it encounters. And I get way too happy talking about this. So of course, then you could say, okay, but are there any fields that are actually like this? Is this actually possible in any way? And the answer to that is actually, well, have you heard of the Higgs field? The Higgs boson, is the particle that gives all the other particles mass. Without the Higgs boson, the universe would look vastly different. The Higgs boson has given everything mass. It's kind of in its stable state, we think. But there is a chance that the Higgs field is the field that is just like made up of Higgs particles everywhere in the universe. And it's the thing that gives everything else mass. There is a chance that the Higgs field looks something. Where did my sketch go? I just showed you a blank piece of paper. There is a possibility that this is what the Higgs field looks like, and that currently we're here in a metastable state. If this is the case, then the Higgs field could at any point tunnel to its new state. What would happen? You get a bubble of the new state where particles have different mass, where the bindings between particles are different. Atoms couldn't exist the way they do currently. If the Higgs field tunnels to its lowest state anywhere in the universe, it is going to create this expanding ball, this expanding bubble of a new universe. And who knows what this new universe is look like, but it would replace the old universe. If this happens, you cannot see it coming. You cannot prevent it. There is literally no way of stopping it. Once it starts, it's going to happen. The only possibility of escaping this is if you're on the other side of the universe, really, really far away. We know the universe is undergoing accelerated expansion. Would this accelerated expansion be enough to outrun this expanding bubble of death? Probably not infinitely, but at least for a while, you could outrun this expanding bubble of death. So the Higgs field could, at some random point, just tunnel into a whole new state. It could take the whole universe with it. It could happen without any warning, without any way of preventing it. No warning, just nothing. In a fraction of a second, not only Earth, but the entire universe as we know it could be gone. Physics itself would be new. We don't know what the new universe would look like. We don't know if life could even exist in this universe or how it would look. So this is fun. It could literally already have happened. It could be on its way to this expanding ball of death, could be heading towards us, and we wouldn't know. If you think this is terrifying, which to be fair, you should, at least based on our current understanding of the Higgs field, this probably is not going to happen for the next 20 billion years. So we'll be long dead, as someone said before, we'll be long gone and dead by then, because the sun is going to expand and wipe us all out. So there are hundreds of ways the universe can kill us, thousands of ways the universe could kill us, ranging from tiny little space rocks thrown at us to the universe literally just saying, okay, I'm going to change the entire laws of physics with a new field. I think my stream is dead based on the lack of comment and the lack of views, but let's just keep going, assuming everybody is still here. Maybe some of you have already felt the heat death, the expanding ball of death of the universe. Probably not, because I would have felt it too by now. So there are tests. I see your tests. Thank you for testing. So at least one person is still succeeding with the stream. So if you have this expanding ball of death, you can't see it coming. There are so many ways the universe can kill us, from asteroids to gamma ray bursts, literally changing the laws of physics. And there's nothing we can do about it. But what we can do is we can control our own lives here on Earth. So I think a lot of these things are scary, especially the vacuum decay, gamma ray burst, asteroids. These things are terrifying. But also, it's kind of reassuring that in the grand scheme of things, we're just this tiny little species lost on a planet, adrift in the universe, trying to figure out what is happening. We might stop existing at any point, but for now, we're here and we have a life to enjoy. So I hope I've given you a bit of existential dread and maybe just a dash of optimism that the universe is incredible and amazing and fun, and there's so much cool stuff happening inside the universe. It might all end someday. It might not. But it is amazing that we know these things, that we can discuss these things, and that we can study these things. So even though the universe is vast and scary and terrifying, I also think it is oddly comforting to know that the universe could just stop existing at any point. Nothing we can do about it. Nothing we could do to prevent it. So that's the wrap on my spooky space facts. Hopefully not too spooky. Hopefully some of you are still here. I know the stream has been extremely temperamental. Sorry about that. I hope the replay works. I'm not sure if the replay is going to work, but let's just hope for the best. So I hope I haven't given you too much existential dread here. Just a healthy dose of existential dread. In any case, I've had a lot of fun reviewing 10 scary space facts, 10 spooky space facts. Spooky space facts is a fun tongue twister. I've had fun reviewing the spooky space facts. I hope you've learned stuff. I hope you've had fun listening. The questions that came through were really fun and interesting. It's been great to chat to you all. Cup of Cosmology should be back online next Sunday, same time as today, which is 8 p.m. Finnish time, 7 p.m. Central European time. As always, there is a time zone converter on cupofcosmology.com, just updated today to reflect the daylight saving time ending. If you don't know when to catch me live, just check on cupofcosmology.com, time zone converter, that will help you. And if, just in case, subscribe to the YouTube channel, and then you'll get a notification 30 minutes before I go live, and then you'll never miss another stream. So thank you everyone for joining. This has been really, really fun. Sorry again for all the technical issues. Really not sure what I can do to fix those. Hopefully next week will be better. I hope to see you all again next week for less spooky space facts, but still cool space facts. I hope to see you all again next Sunday. And in the meantime, I hope you all stay safe and take care of each other.